Okay, so I'm going to show how to solve a three equation, three variable system. Just like with the two equation, two variables. I need to get rid of them in a certain order though. So let me show you this. I want to get rid of that guy first. Then I want to get rid of that guy second. If I get rid of those two guys, the bottom two equations we can treat like a little, two equation, two variable system, and then I can get rid of that one third, and then all I have to do is solve for each of the variables and back substitute into all the different equations. So let's do that. So the very first thing is I need to get rid of that x on the third equation. So I'm going to take that and, well, let's see. What I want to do, let's multiply it by -1 so that we can match it up with that top equation. So that's going to be, top equation we're not changing, second equation we're not changing. Last equation we're multiplying everything by a negative. Then we can add it to the top one and get rid of that x on the bottom. So in the next step, doing nothing to the top equation, doing nothing to the middle equation. Okay, now we're getting rid of the x on that third one, so it goes away. Then I get 2y, and then I get plus z equals -1. Okay, then I'm going to get rid of the 2x on the second equation, so I'll need to multiply the top one by -2. So I get -2x minus 6y minus 4z equals 1. Bottom equation doesn't change. Adding those two. Now, the top equation, I have multiplied it by a number, but I'm using it in this step. So what I want to do going into this next step is let's go ahead and revert the top equation back to the original form, just so that we don't make it too complicated and then get big numbers and stuff like that. So the two x's go away. Then I have -6y plus y, so it's -5y. I have -4 plus -1, -5z, and then 1 plus 2 is 3. I think I made a mistake. I did. I did make a mistake. Let me show you where I made the mistake. Right here, that should have been a -2. So then in this next step, 2 and -2 should have gave me 0. Sorry about that. These are very easy to make mistakes on. You gotta be very careful and look at every step carefully. So then now, I need to get rid of that 2y on the third equation. So you see I have a -5 right above it, so I can match them up by doing one is -10 and the other one is 10. So I'll multiply this one by 2, this one by 5. Top equation stays the same. Second equation is -10y, -10z, 0. 10y plus 10z equals -5. Add those two. Top equation is x plus 3y plus 2z equals 1. I can revert the second equation. Last equation we get 0. Oops, I made another mistake. Oh, I'm so sorry. That should have been a 5. So anyways, -10y and 10y is 0. -10z and 5z is -5z. And 0 and -5 is -5. So then here, you can see, given this guy, that z is 1. Substitute that into the second equation. Get negative 5y minus 5 is 0. Add 5 to both sides. Y is negative 1, not negative 2, negative 1. And I'll take both of those and plug it into the top equation. X plus 3 times negative 1 plus 2 times 1, 1. So we have x minus 3 plus 2 equals 1. So we get x minus 1 equals 1, or x equals 2. So the solution is x equal to 2, y equal to negative 1, and z equal to 1. Okay, now I want to do another little bit harder system. I mean, the exact same method, it's just going to be a little bit more difficult. Let's do 8x minus 3y plus 6z equals negative 2. And I don't want to really say the rest of it, so I'll just write it down. Okay, now I want to get rid of the 12x first. So I want to do that by multiplying the second equation by negative 3. Last equation stays the same. I'm going to add those two to eliminate the 12x in the bottom equation. Top equation stays the same. Second equation, I'm going to revert it. Okay? I have multiplied it, I'm going to use it, but let's revert it back to a simpler form. The last equation is the one we're changing. So negative 12x and 12x is 0. Negative 27y minus 3y is negative 30y. Negative 12z and positive 8z is negative 4z. And negative 54 and negative 2 is negative 56. Okay, now I'm going to get rid of the 4x in the second equation, and I can multiply that by negative 2 to make it match up with the 8x in the top equation. So let's do that. Okay. Add those two equations to change the second one to get rid of it. Top equation stays the same. Middle equations one's changing. 8x and negative 8x is 0. Negative 3 and negative 18 is negative 21y. 6 and negative 8 is negative 2z. And negative 2 and negative 36 is negative 38. Now, I need to find the least common multiple of 21 and 30, which is 210. So I need to multiply this one by 10 and this one by negative 7. Top equation is that. Middle equation is negative 210y, negative 20z, negative 380. Last equation is going to be 210y plus 28z, and then negative 56 times negative 7 is 392. When I add those two, top equation stays the same. Second equation, I'm going to revert it back to a simpler form. Then the last one's one we're changing. The negative 210 and 210 go away. Negative 20, positive 28 gives me 8z. Negative 380 and positive 392 just give me 12. Okay, so we're done with all of our eliminations. Let's solve for all the variables. The bottom equation gives me 3/2 for z. Substitute that into the middle equation. Negative 21y minus 3 equals negative 38. Add 3 to both sides. Look at that. Y is 35 over 21, or 5/3. The last equation, 8x minus 3 times 5/3 plus 6 times 3/2 equals negative 2. So 8x minus 5 plus 9, negative 2. So we have 8x plus 4 equals negative 2. 8x equals negative 6. X equals negative 6/8, or negative 3/4. So the solution is negative 3/4, 5/3, and 3/2. Okay, next time we're going to talk about matrices and how to solve these systems using matrices.